Hello, we are going to begin episode number 3 of SAT Math Hard Practice Level Questions. This will be part of Algebra and Functions, and we'll be going through questions 1 through 5. We will also be answering a question from the comments that someone has asked for, and that'll be at the end of this video. So let's start off with question number 1. Let m be an even integer. How many possible values of m satisfy the square root of m plus 7 is less than or equal to 3? So I'm seeing this question, I'm seeing that we could probably solve for m on the left side, and then we could get our following range. So we have square root of m plus 7 is less than or equal to 3. We could square both sides. We'll get m plus 7 less than or equal to 9. Then we'll get m is less than or equal to 2. But then there's also another part that we cannot forget, is m cannot be less than 7. If, oh, my bad. M cannot be less than negative 7. Because if m is less than negative 7, m is going to become a negative number, and you cannot square root a negative number. I guess you could solve this out quantitatively through, we want m plus 7, and we don't want it to be less than 0. So then m is less than negative 7. So we get these two ranges. M is less than or equal to 2, and m is less than negative 7. And then the question asks how many possible values of m, and m is going to be an even integer. So let's go through this range. We got 2, we've got 0, negative 2, negative 4, and negative 6. And we can't go negative 8 because negative 8 is less than negative 7. So we have 5 values. So for question number 1, the answer is E. Question number 2. Let x be defined by x is equal to x plus 3 over x minus 1 for any x such that x does not equal to 1. Which of the following is equivalent to x minus 1? So these questions are scary, but once you find a trick to do them, they're actually very easy. Believe me, please. X is equal to x plus 3 over x minus 1. Which of the following is equivalent to x minus 1? So you might be, you're going to try to algebraically manipulate this equation, but you can also see that we have x here. In order to get x minus 1 on this left side, we can minus 1 here. But whatever we do to the left side of the equation, we have to do to the right side, minus 1. Now you might be wondering, what do we do from here? We have x minus 1 is equal to this. But these are none of the answer choices. Over here is now where you start algebraically manipulating this 1. We want to get looking for the answer choices, they have an x minus 1 in the denominator. This is x minus 2, but let's just disregard it. These answer choices have x minus 1 in the denominator. So how come we can't just make 1 into a fraction with a denominator as x minus 1? Sorry if I write my x's weirdly. Got into a habit with it. So the denominator is x minus 1. That means the numerator also has to be x minus 1 in order to get this part to equal to 1. Now from here, we have common denominators and we can just subtract. Remember, this minus applies to both x and the minus 1. So here. Then this is going to become, the x's cancel out, minus 1 becomes plus 1. 3 plus 1 is 4. 4 over x minus 1. And that should be answer. So our answer is B. Let's move to question number 3. Let a and b be numbers such that a cubed is equal to b squared. Which of the following is equivalent to b radical a? So I'm looking at the answer choices and I realize that the only variable part of these answer choices is b. So that means I want to substitute radical a in terms of b. And we have the following equation: a cubed is equal to b squared. We want this radical a to be represented in terms of b. So that means we already have a on the left side and b on the right side. That means if we could get a cubed equal to radical a, and then change whatever we do to a to whatever we change to b, then we should get radical a in terms of b. So how can you get a cubed to radical a? Well, the square root is actually just a to the power 1/2. Whenever the exponent is less than 1 but greater than 0, you're going to have a square root, a cube root, a fourth root, etc., etc. Alright, so we need to get a cubed to become a to the 1/2. So how do we do that? Well, with exponent rules, let's do this. We know we can multiply this by some exponent with a question mark. Now we'll have to raise a cubed to the power of something in order to get, because remember from your exponential rules that when you exponential a power, you're going to have to multiply the powers. So we know that 3 times this question mark is equal to 1/2. We divide by 3 by both sides. The question mark has to equal to 1/6. So that means we're going to raise this side to the 1/6. We also have to raise the right side to the 1/6. What do we do on the left side? We have to do to the right side. So this becomes a to the 1/2. This becomes b to the 1/3. Now, we have b radical a. Radical a is equal to b times b to the 1/3. It's another exponential rule. When you multiply two powers with the same base, you just add the exponents. So b to the 1 plus 1/3. That's just equal to b to the 4/3. p to the 4/3, is that an answer choice? Yes, it is. Yay, let's go. 3 is going to be b. That's nice. Very cool. Yeah, let's go take all this away. Oh no, I went too much. Okay, question number 4. Let m and n be positive integers such that 1/3 of m is n less than 1/2 of m. Which of the following is a possible value of m? So I'm reading this, and we could see that we could translate this word expression into a mathematical expression. So let's go ahead and do that. 1/3 of m could be replaced with an equal n less than 1/2 of m. This means that this is equal to 1/2 m, and then less than, you subtract n. N less than 1/2 of m. Now, I'm going to make this easier because we have to try to compare m to some certain value of n and then get one of these numbers. So I'm going to multiply this whole expression by 6 to get rid of the fractions. No one likes fractions. 6 times 3, 2m. 6 times 1/2, 3m. Is equal to right? feel like I'm doing this wrong. Am I doing this wrong? Am I doing this wrong? 2m is equal to 3m. Oh, my bad. I didn't multiply the 6. Sorry. Let's go. I was very confused there for a second. 6n. Now what we're going to do is solve m. Let's go minus 3m both sides. We get negative m. Negative 6n. Take the negatives out. M is equal to 6n. Now with the information here, m and n have to be positive integers. So m and n both have to be positive whole values. Now from what I can see here, I can see that m has to be a multiple of 6. The reason is why is because n has to be a whole positive number. And when you multiply whatever number by 6, we know we have to get a multiple of 6. Now, which of these answer choices is a multiple of 6? There is only one, and that is answer choice C. And if you put this C back into the equation, it'll probably work. Hopefully. Let's see. So m is going to equal 24. 24 is equal to 6n, and it equals to 4. Put this back here, 1/3 of m. 8, 1/2 24, 12 minus 4. 8 is equal to 8. Indeed, that is a true statement. 4 is C. Sorry I blanked out earlier. I don't know if I got everything there. Yes. Question numero 5. If A and B are numbers such that a minus 4 times b plus 6 equal to 0, what is the smallest possible value of a squared plus b squared? So, I can already see how to do this one. So we have to satisfy this equation here. And then we have to minimize this so we get the smallest possible quantity of a squared plus b squared. Well, first of all, with these quadratics, in order to get the right side to be 0, one of these in the parentheses has to equal to 0. If this is 0, then no matter what this is, 0 times anything is 0. Or if this is 0, 0 times anything is going to be 0. So, let's see. Let's choose. In order to get a minus 4 to equal 0, a could equal to 4. In order to get b to equal to 0, b could equal to negative 6. Right? But let's look at the scenario a is equal to 4 first. If a equals to 4, this side becomes 0. If this side becomes 0, this number could be anything, because anything times 0 is 0. So that means b could be literally any number. And if you want to minimize this, I think the best choice is obviously to use 0. So we're going to get 4 squared plus 0. Or just 16. If you use b equals negative 6, we already see that this comes into a problem. Negative 6 squared is 36. We can never get a to be a negative number because we're squaring whatever is in here. So as a result, even if we try to minimize a to be now equal 0, because remember, b equals to negative 6, this is 0, this number can now be anything, so we can minimize it by a equal to 0. This is still becomes 36, which is greater than 16. So we're going to use this pair to get this small number. So 5, 16. Hello. So we are now going to go over a question that someone in the YouTube comments has asked me. And yes, this is it. I'm going to need to... Pretty sure I could save image as... So I have a lot of folders. We can open this. And let's look at this more closely. How do we... Yes. Then can I scroll up? Thank you. So let's look at question number 8. So I think she wants, or he, I think it's a she, but I can't assume. Yes, question number 8. On the release date a vendor puts 8,000 tickets to a particular concert up for sale. After 5 hours, 38% of the tickets have been sold. If the tickets are sold at a constant rate, which of the following functions and models the number of tickets still available T hours after the vendor put them up for sale? So just by reading this question, we have one important key detail, and it's this idea that they're sold at a constant rate. If they're sold at a constant rate, that means that these functions, there has to be linear, because when you have a constant rate, you have a constant slope. When you have a constant slope, it's going to be a linear slope. So already I can knock out C and D because these are exponential functions. These are not linear functions. So it's either going to be between A and B. So we can cross C and D out. You know what? Maybe I can do this. Copy. Can I copy you? Yes, thank you. Hopefully this isn't. Oh, that's nice. Then let's cross out C and D. So it's either going to be between A and B. So we have information. Puts 8,000 tickets. So when time is equal to 0, n is equal to 8,000. After 5 hours, 38% of the tickets are sold. This will give me another time. So when t is equal to 5, n is equal to 38%. Oh, my bad. 38% of 8,000. So all we have to do is just put that in our calculator. So let's go do that. 38%. I don't know right now. 38% of 8,000 is 3,040. So now, because we know we have a linear function, we could then just find our slope, our y-intercept. So our slope is going to be m is equal to y2 minus y1 for x2 x1. My handwriting's bad. 3,040 minus 8,000 divided by 5 minus 0. Put that in our calculator too. 740 minus 8,000 divided by 5. And that's not what I wanted, really. Oh, I am sorry. I should have read more. I should have read this. 38% of the tickets have been sold. So that means 3,040 tickets have been sold, which means that, and then we want n, which models the number of tickets still available. So it actually has to be 8,000 minus 3,040 because we sold 3,040 tickets. My bad. I am very sorry. Take that away. 4,960. And let's just cross this out. No one saw it. Get rid of the evidence. And you know what? This just goes here. So 4,960 minus 8,000 divided by 5. I apologize for that. Negative 608. And we can already see from one of our answer choices, the slope is negative 608. So the answer choice is going to be B. Yay. Let's do question 9. Let's see, and then let's here. On certain days of the week, Elaine runs for an hour on a treadmill. For each day that she ran in the last week, the table above shows the average speed s at which she ran in miles per hour and the number of calories she burned during the run. If the relationship between c and s can be modeled by a linear function, which of the following functions best models the relationship? So once again, we have a linear function. We get c, which is a function of s, and that's interesting. Okay, so they actually give us certain values for s and certain values for c, and if it is given that this is going to be a linear function, then we could just select 2 points, find the slope, and find the y-intercept. So let's first find the slope, I guess. Yes, let's find the slope. So once again, m is equal to y2 minus y1 over x2 minus x1. So let's choose the ones that look pretty nice. So I like I like Thursday. Actually, no. I like Fridays and Saturdays the best. So let's choose that. So let's make Saturday to be y2 x2 and Friday to be x2 y2. C is in the y because C is a function of S. So S becomes the x because this is the independent variable. C is the dependent variable. So C, 720. Y1, we're going to choose Friday to be Y1 and Saturday to be Y2. 672 over x2, 8.5 minus 7.9. Let's put these in our calculators. 720 minus 672, 8.5 minus 7.9, 48 divided by that. That's going to give us a slope of 80. We see that our slope is 80, so we could obviously just see that C is going to be our answer. But I'll just solve the rest for you, just in case. Never know. So there's a certain formula called point slope form. All you need is 1 point and the slope, and you'll be able to get the whole linear function. And the way it works, I believe, is this: y minus y1 equal to m times x. It's x1, where x1 and y1 are the points you choose, and m is the slope. We got our slope 80. So I do like Saturday better than Friday, so I'm going to choose a point Saturday, and the point is 8.5, comma 720. Remember, 720 represents y because 720 number of calories burned is the dependent variable. .5. Let's do some math. 80x. I'm running out of space. No, white space, don't leave me. 8.5 times 80, 680. Once you add 720 to both sides, you'll get y equals to 80x. Please let me have more space. I do have more space. Plus 40. And C is our answer. C is our answer. Yeah. Let's go. Let's do it. Oh yeah. So I hope I answered these questions correctly. I hope I did. Hopefully. And if you guys got any more questions, just put them in the comments. I'll do my best to try to answer them. And thank you.